After the spring break, I'll give you the rest of the homework sheet. I think I just printed out like the first part, and I've updated it many times, just because. So after the spring break, I'll give you the one that goes all the way up into the final. You can see when all the other tests are going to happen, and what they're going to cover. Yeah, some people call every test they give a midterm, which is hilarious to me. You guys have midterms in any classes?
Yes.
What's a real midterm, though? Do you know what a real midterm is? It's like a final halfway through, right? It's cumulative all the way up. So I've only ever done a midterm when I was teaching online. It's easier to do it that way. I did like 15 quizzes and a midterm and a final when I was teaching online. Of course, when I was teaching online, everything sucked. So it's not the way I wanted to do anything. So I'm not going to do that ever again. So are you? Yeah, this feels like about the time for midterms. I'm sure some of you guys had some midterms this week. No? Okay. Yes? No? Maybe? Sort of? Okay. All right. Anything else about this class? Homework stuff? Stuff from the test? Anything? Does everybody have this sheet still that's up here? Anybody else need it?
Yeah.
So on the other side of this, you'll see this. That's what we're going to work on right now. All right. All right. If you guys have no questions, we're going to try to do this stuff here. So in the homework, somebody actually asked me a homework question earlier. It's basically exactly like number one. Let's do this. Remind me what, shoot, I need paper. Here we go, paper. Remind me what this would be. Log what now? When do I add? Remember, what are logs? What are logs? They're always what? Logs are always powers. When do I add powers? When I was multiplying. This is how you remember these properties. Why do they have the same properties? Because logs are powers. So what's log A minus log B? Log of A over B. Kick ass. I like it. And what is log A to the M?
M log A.
Yes, this just comes down. Kick ass. And it can go back up too. So all of these can go both ways. Right? Okay, I like it. Hey, Mikey. Little trick question. Little trick question. What's this? The answer is I have no idea. There's no formula for this. There's nothing. You just do whatever you can. There's no way to simplify this. I need you to understand. This says the sum of two logs.
Just need one of that.
Oh,
Sorry.
the sum of two logs is the log of the product, right? It says nothing about the log of the sum. You guys kind of with me? Really easy to mix those up. Okay, I like it. So, I mean, what this relates to is, if I was adding two things with the same base, but they did not have the same power, can I do anything with this? That's exactly what this is saying. I can't do anything with that. Okay. But if I'm multiplying two things with the same power, can I do something with this? Yes.
You can,
I can add the power. So that's exactly what this says. If I'm multiplying two things with the same base, I can add the powers. It's exactly what this first guy says. How you guys doing? That's why I make a big deal out of logarithms being powers, because then these properties make nothing but sense, is my hope. So, can we use these properties? Do I have a property that says anything about twice a log plus another log?
yeah,
No, I don't. I know what log plus log is, right? Log A plus log B is log A plus A times B, right? Do I have a property that says anything about 2 times a log plus another log? No. Do you all agree with me then that that 2 is in the way? If that 2 wasn't there, I could combine the first two things. You guys agree? Okay. So where can I always love when I ask this kind of question. Where can I put that 2? I'll tell you where to put it, Jeff. No. Where can I put that 2? What am I allowed to do with it? I can put it back up here, yeah.
that's not the power rule?
Say again.
That's not the power rule?
What do you mean? Sorry.
Right here, power rule.
Okay, yeah, that's what that is.
Yeah, you just said we didn't have a rule.
What? Okay. I said, what exactly? What did I say?
Never mind.
Okay. Okay. So we don't have a rule for log of A plus B. That's what I said. We definitely have a rule for the power can go back up, can come down. That one we know. Yeah.
You asked, do we have a rule for?
Do I have a, no, okay, help me out. What's log A plus log B? Log AB.
Right.
Do I have a rule for twice log A plus log B? Can I immediately rewrite that? No. I don't have a rule for 2 log plus log. So I want to move the 2 out of the way. Now do I have, let's just focus on this first piece. Now, do I have log plus log?
Yeah,
For some reason, it's got a big old O, but oh,
y squared
okay. What can I do over here at the same time? What do I need to get out of the way?
Negative half.
Okay, so I'm going to look at it this way first. I'm going to bring the 1/2 up. The same way we brought the 2 up, is that cool? I need to get the coefficients out of the way, because then I have properties for log plus log and log minus log, right? I forgot my poor little 3 dude.
Yeah.
Okay, let me stop for a minute. So, do you all agree with me that I have a property for log base 3 plus log base 3 of something? Yeah. I don't have a property for log minus 1/2 log. I don't have a property for that. So when I'm trying to combine all this stuff into a single log, the first thing I need to do is get my coefficients out of the way. Because then I'm left with log plus log minus, okay, I got properties for those, right? So what can I do with the first 2 things here? Yeah, this becomes log base 3 of y squared times a. Is that cool? And now what can I do with this log minus this log? So what exactly goes inside?
Y squared plus times a over W R1.
I love it. Kick ass. Let me stop for a minute. The way I do these problems, and of course, I've just been doing math for a long time. From the very beginning, I knew that this term is going to end up on the bottom because it's the only one that's being subtracted. So I know I'm only have one thing on the bottom. Everything else is positive, so I'm going to have a couple things on the top, right? So this makes complete sense. Okay, I'm just going to proclaim that. Let me know if you don't agree. Let me do this a different way. I'm going to do this problem a different way. That problem's done, but just really quickly, yes?
So the way like I did, like I showed you, could that W be like a root W?
You could rewrite this as a square root.
Okay.
There is absolutely no reason to, but you could.
Okay.
All right, so we already got this. This is perfectly valid. I love it. tiers. This is perfect. I'm gonna show you a different way. Just to show you get the same answer. So, I'm gonna do this again. I'm gonna bring the 2 up. The middle dude is awesome, you're awesome. This time I'm gonna take the negative 1/2 up. You guys see that? That's a choice I can make. I can either take the 1/2 up and leave the negative down here, or I can take the negative 1/2 up. Let's see if we get the same answer now. Is everything adding now? Everything's adding. So we got y squared a w to the negative 1/2. Is that cool? And I have log plus log plus log. I just put all the insides, slam them together in the inside, yeah?
Yeah.
Is this the same answer as what I got before?
Yeah, sure.
Are these the same?
Yeah.
Why? Why are they the same? Because this wants to go down. So no matter which way you decide to do these, and there's almost always some kind of a choice somewhere, you'll come out the same way as long as you do the steps correctly, right? Okay, how we all doing? Yes?
Can you write a negative exponent in your final answer? For this?
No, yeah, it's convention to not leave negative exponents, yeah. So just make sure your answer doesn't have any negative powers, yeah. It's just convention, it's just what we do traditionally. Okay,
Negative flips.
so there's several problems in the homework like this, and they basically say exactly, write the following as a single logarithm. This is exactly what you do. Now, here, remind me, how could I rewrite this problem here? How do I rewrite that problem as an exponential? 7?
7 raised to the second equals x.
So x is?
7 squared. Oh, it's 49.
Okay, so did we just solve that logarithmic equation?
Yeah.
Yeah, cool. So some logarithmic equations, I just have to rewrite them and then I've solved it. It's kind of crazy. But look at this problem here on this thing. How is that fundamentally different from this? What's the obvious immediate difference?
X minus 12.
No. How many logs are on this side here?
What?
1. So then I have a single log so I can make its base go to there and then equal the inside. Can I do that here? No, there's 2 freaking logs here, right? If only we had a way to kind of like make that a single logarithm. Do I have a way to kind of put those 2 logs together?
Yes.
Put
Do
one
they have
on
the same
other.
base?
Yes.
Yes, so then I'm allowed to do what?
Add or the divine.
I'm subtracting powers. I must have been dividing. So this is the true usefulness of the properties of logarithms. What is, like, if I said, think of algebra, first thing I think some of you guys are going to think about is, like, letters. Some of you guys are going to think about word problems. But we all should eventually think about solving equations. It really fundamentally is, how do I solve any damn equation that I could run across? Because in the real world, we model what's going on with equations and then want to solve it so I can make predictions, like where's that hurricane going to go, right? For example, or when's there going to be an earthquake or whatever, right? Trying to come up with a natural disaster that we have to worry about. So remind me, what did we do here? We got a single log equals a number. The first thing I did was rewrite it.
Right.
Can I rewrite this? 4?
4 to the first.
4 to the first power equals?
X over x minus 12.
Kick ass. So now that's become like a chapter 2 problem. Now, does anyone know what to do from here? What of course is the worst part about that equation? Yeah, there's a freaking fraction. How do I immediately kill any fraction in any equation?
Multiply it by the
Multiply by the denominator.
denominator.
Denominator. So I multiply both sides by x minus 12. What do I get? Here I'll get what?
4x minus 48.
4x minus 48, and on this side I'll get x. Keep going, finish that real quick. That should be gimme.
I got the whole thing written down. 3x equals 48,
Good, you can subtract x and add 48.
and x equals 16.
Divide both sides by 3, you get 16. Now, real quick. Whenever you solve a logarithmic equation, just like square roots, when I solve a square root equation, what's the last thing I need to do when I get numbers? I have a radical
Positive.
You
equation.
have to prove it.
Positive, negative?
Does anyone remember? You get, let's say you solve a radical equation and you get some numbers. What do you have to make sure about?
Check them.
Check them. Because you might have some that don't work, right? Logarithms are very much like radicals. Whenever I get an answer at the end, I have to make sure that they both work. What can a log not handle inside? What kind of number can a log not handle?
Negative.
Negative or 0. Does 16 make either of those logarithms have a negative or a 0 inside? No, right? So it's good.
How'd you get the 3x?
Oh, subtract x,
Oh.
add 48. Yeah. Or you could here, you could subtract 4x and divide by negative 3. You'll still get positive 16. Right. Okay. Everybody with me? You guys someone with me?
So if you plug in the 16, it's gonna be log 4 of 16.
Yeah, let's check it.
2 minus 1.
Yeah, what's log base 4 of 16? Log base 4 of 16?
2.
2. And what's log base 4 of 16 minus 12? Log base 4 of 4.
1.
And what's 2 minus 1?
1.
Yay, okay, so you can check your work, of course, yeah. The most immediate thing you need to check is to make sure it does not make the inside of any logarithm 0 or negative. Because logs can't handle that kind of input.
So if you wanted for the second one, if you wanted the x is negative, that means that's undefined.
Yeah, if this would have been minus 18, and I try to plug a 16 in, I would have a log of a negative number, then I would have to say there's no solution.
So you just x that out.
Yep, just like we do with radical equations, right?
Log b is correct as well.
Say again?
I already presented b, but.
Oh, okay, let's not do that. Yeah, okay. Part B is exactly the same as part A. I have too many freaking logs. If I just had one log, right? If I just had this, if that's all that was there, what could I do? How could I rewrite that?
Log x over log.
No.
W to the third power.
So real quick,
of x.
I have no property for the log of a difference. I have a property for the log of a quotient, and I have a property for the log of a product, right? I have no way to rewrite this, but I can, this logarithm, but I can rewrite this as 3 to the third power, right? Now, unfortunately, I don't have a single log, but can I do something so I end up with one logarithm?
Yeah, multiplied.
Yeah, I'm adding logs, so what do I do with the insights?
Multiply.
Multiply them. Let me stop for a minute. So again, I need at this point, this problem right here has to be easy. Because all you have to do is rewrite it in exponential form and you've essentially solved it. So my variable's on the inside of a log. If I can just make it so there's one logarithm, I can rewrite it and solve it. That's what I can do. So the whole idea here is we've now learned a way to put these together to be one logarithm. How do I rewrite this?
Log base 3.
No.
Oh,
3
yeah.
to the
Third.
equals?
X squared minus 4x.
Yeah,
minus
okay,
5.
let's do that. X squared minus 4x minus 5, is that cool? So anytime I have a logarithm, I can rewrite it as an exponential. Why does that help me here? Because at first my x's were stuck inside of a log, now they're not. How do I solve that thing? What's 3 cubed? 27. How do I solve this?
Minus 27 brings
Yeah, this is our bread and butter. I got an x squared term, I got to get it equal to 0, and then I have to factor it, right? So sometimes I have students that think, but we left that section behind. No, we never leave any section behind. Any damn thing we've ever learned can suddenly show up anytime it wants to. I don't know if that probably makes you feel uncomfortable, but I need you to understand. Don't discount that because you're like, oh, we're not in that section. No, it could happen. So, yeah, subtract 27. So now I get x squared minus 4x minus 32 equals 0, right? And then, of course, yeah, two numbers that multiply to be negative 32 and add to be negative 4. Oops.
One of them is negative.
Yeah, so I get x equals negative 4, and I get x equals 8. Now, obviously, now be careful. Don't throw it out because it's negative. For example, if that was a plus 7, would it be a problem that this is negative 4? Not for that log, right? So you gotta, but does negative 4 make either of these negative on the inside? Yeah, it makes them both negative. So I can throw out negative 4. You can't be an answer because logarithms can't handle negative inputs. What about 8? Yeah, 8 works. 8 does not make either inside non-positive. Is that? Okay. Yeah, it does. All right, so if I want to check this,
Wait, why is it 4 and, or negative 4 and 8 and not the other way around?
you're okay with this?
No.
Oh, all right, so I need
Is
two
this
numbers
actually flipped?
that add to be negative 4.
Mhm.
So then 8's got to be negative.
Yes.
Okay, so you're okay with this?
Oh, but doesn't that mean you would flip the signs in the parentheses? Is that what I'm asking? So because when you do it, it's 4 times negative 8?
How do I factor this? Do you agree I factor that like this?
No. Because wouldn't it, because the factors would be 4 and negative 8, so wouldn't it be x minus 4, x plus 8?
You're thinking as if, so the step you do to figure out the correct numbers, you're not solving anything yet. You're trying to think backwards to begin with. No. You factor that like that. If I multiply this out, don't I get 4x minus 8x negative 4x?
Yeah.
Yeah.
Okay, so you're thinking what we just did here. If that's a plus 4, the answer is negative 4.
Yes.
Okay. It's not what happens here, because if I change these signs, I don't get this. I get plus
Okay.
4, and that can't be the way to factor it then. You're thinking this step, but you're thinking that step too early.
Okay.
Yeah, factor that directly, like we always would, and then the shortcut is, it's the opposite sign.
Okay,
Yeah.
got it.
Okay. Now, if I want to check 8, 8 plus 1 is 9, that's crazy. What's log base 3 of 9? 2. 8 minus 5 is 3. What's log base 3 of 3? 1. And what's 2 plus 1? 2. So as always, I don't care what the equation looks like. When you get an answer, you can check it. Okay. No matter what the hell it has in it. That's always nice. You can always check it. All right. How we doing? Yes.
Wait, how did you check the
Just plugged it in. So if I want to check 8, I plug an 8 in. 8 plus 1 is? Log base 3 of 9 is? 2. Yeah. Okay. I just didn't want to write all that stuff out. Okay. All right. So again, the whole motivation is, here, you guys, help me out. Solve this. What you got, Jeff? Take a minute to solve that equation. What's the first step?
2 to the 4th equals x minus.
Yeah, so I can rewrite this as an exponential. So I get x minus 1 equals 16, so I get x equals 17. So, if my problem had actually been, let's see if I can make one that works. Would that be nice? That'll work. Just trying to be a minus 1 there, poor little dude. I can't do it as simply as this one. This one is easy because I know how to rewrite a log as an exponential. Here I've got too many freaking logs. So of course my motivation then is, do I have a way to rewrite this as one log? Because if I do, I could do exactly the same thing we did here. So of course in this case, how would I make it a single log?
X squared minus 1.
X squared minus
X.
x. Yeah. So if I just rewrite it as, since I'm adding powers, that must mean I was multiplying stuff. So x times x minus 1 is this. And now I've got a single logarithm. So I can do exactly the same idea. 2 to the first power equals that. Is that all right? Now it's a little bit worse because I have a higher degree, but the process doesn't care about that. We care about that. We're the humans. We got to do this shit. The idea didn't care. Now I've just got to figure out how do I solve that. And of course, since I have a square, I try to get it equal to 0. How do I factor this? Yep. So then I get 2 and negative 1. Are both of those okay? And I want to point out, so every time we get an answer that doesn't work, even though I did all the frickin' steps right, correct? As a student, this has to anger some part of your brain, maybe the entire brain. I did all the steps right. I'm the frickin' teacher. I did all the steps right, and I still get an answer that's not right. What the shit? So, but when I multiply x times x minus 1, if those were both negative numbers, x and x minus 1, if they're both negative, what do I get when I multiply them together? Positive. So as far as the math knows, this will work more often than it should. Because when I multiply those together, if they're both negative, this is positive. And the math is like, okay, this works. Sure enough, if I put a negative 1 in, this is negative, and this is negative. But what's this when I put a negative 1 in? It's actually 0, right? So it's fine. Okay. Well, not really. No, it can't be. But it's negative times negative is a positive, right?
It'd be negative 2 times.
So it'd be negative 1 minus negative, it'd be 2. That's better. Yeah, not 0. So if I put a negative 1 in here, 1 minus negative 1 is 2. So as far as the math knows, this problem has 2 answers. We know we started up there, right? I don't know if that makes any sense. I always want you to understand, why does the process give me an answer that doesn't work when I did all the steps right? Because the first step we did, we might have multiplied 2 negatives together. So the math is going to answer this question. And then we're like, oh shit, it doesn't work in the original. My bad. So I got to throw out negative 1. Does 2 work? Yes. Yeah. Log base 2 of 2 is 1. Log base 2 of 1 is 0. 1 plus 0 is 1.
I got a question. Slide that up a little bit. X squared minus x minus 2, it should be, oh, yeah, okay, you back did it right. I thought you said 2 times negative 1, but you were jumping ahead of a thing.
Okay.
Okay.
So coming back to this. Now we take a step back in time a bit, but what's the difference between C and D? I can do something with C that I cannot do with D. Do you guys notice what I can
You
do?
can reduce that, like you make like 3 squared.
Yeah. So part C, both bases are based on the same number, right? They're both based on what number?
3.
3. Careful. 27 is not based on 9. 9 to what power is 27? Nothing nice.
Okay.
So 9 is 3 to the,
Second,
holy shit. And then 27 is 3 to the
third.
third, holy shit. The only way this statement can be true is if the powers are equal, because the bases are already equal. Do you guys get that? So now I can just focus, what do I get in this power? 2x. And what do I get in this power?
6x minus 3.
3. Gotta multiply the 3, right? Okay. And then I can solve this pretty simply. Is that alright? So I'll get, like, if you do it this way, you'll get 3/4. Let me stop for a minute. And that is an answer that you could not really figure out from the beginning. We really have to do the algebra. Right? Okay. Can I do the same thing on part D? No, 53, what the shit? It's not based on 7. You could give me an estimate.
I just wrote down x is between 7 and 8.
No, be careful. 7 to what power is close to 53?
Oh, the second.
Second power. 7 squared is 49. So I know the answer is a little more than 2, correct? If I was forced to think of an estimate, I'd say 2.07 just to be, you know. You guys got it with me? Okay, now I'm showing off some of what I do in my head when I get stuff close. Anybody have a suggestion on, besides runaway screaming, how do I solve this? Yeah. So the fundamental problem is my variable is stuck somewhere. I can't do anything. I can't get x by itself because it's currently stuck up top. The only function I know of that could bring a power down like I need is a log. And I told you last time, the log that I always use, ln. Because it's one of 2 that's on the face of the calculator, and it's the one that has the least letters. So you got one less letter to write. Okay. Can you use log if you want to? Shit, yeah. So if I take a ln of both sides, I'm not multiplying both sides by ln. That doesn't make any damn sense. I'm taking the natural log of both sides. What does that do for me again? That looks worse, Jeff. Why did you do that? What does that do for me? Yeah, now I can take this x down. And then how do I get the x by itself? If you have a calculator, could you see what that is? Be really careful. Remember, it opens a parenthesis for us, which kind of sucks. So if I do natural log of 53, I got to remember to close that parenthesis before I keep going. So 2.04. Okay. And if I want to check that, 7 to the that is supposed to be 53. Yay! I don't know if you guys are with me. Okay. So real quick, I'm sorry. Let me say this real quick. If I said round it to 2 decimal places, fantastic. Which one of these is the exact answer? I've circled both of them. All I know is like, let me hedge my bets.
The LNs.
Yes. Not the 2.04. Of course that's not the exact answer because I left a lot of shit out of that one, right? But a lot of students will look and say, well, it's got a decimal. That's the exact answer. No, natural log of 3 over natural log of 7 is the exact answer. But if I asked you how far away you live, and you said natural log of 53 divided by natural log of 7 miles. So if it's a word problem, I need the 2.04 feet, inches, mile, whatever the shit it is, right? On a test, I'm going to ask, I want the exact answer and an approximation. So I'm going to basically want you to do exactly this, right? You guys all with me? It's not too bad, right? So let's try one out that's bad. All right. This problem I'm about to show you, it's got the same idea. It's just a bookkeeping problem. What the hell do you mean, Jeff? I'll show you. Okay. So what if I had, what you got, Jeff? 13 to the x plus 3 equals 108 to the 2x minus 1. Oh man, I'm really, oh God. Okay. For some reason, I wanted to make a really horrific problem. So unfortunately for us, the bases can't be rewritten in terms of each other, right? They can't be rewritten in terms of something else. So what do I do? Do I erase it and hope Jeff doesn't notice I didn't do that one? What do I do? You guys know, my variable's stuck on the top, so what do? Take a natural log, yeah. So take a natural log. I'm gonna write more than I normally would just to make sure you guys see what I'm doing. So I took the natural log of both sides, just like taking the square root of both sides or cubing both sides. Now what can I do with this and this?
And move them down to before.
Come out now. Here's where you got to be really careful. If you write this, you are wrong.
You better put it in parentheses.
Exactly. Because it should be whatever this power is that multiplies by this. And if I don't have the parentheses, I'm just multiplying by 3, not by x plus 3 yet. Does that make sense? That's the first immediate thing you can do that leads to bad stuff, right? Now, real quick. If you did that here and kept going, you're going to get the wrong answer. But you have applied 2 ideas correctly, so I would give you most of the points. But that is a mistake. You'd lose some points if you didn't have put these parentheses. Okay. So everybody understand why they have to be there. Okay. Now what the hell do I do? So here's the general idea. How do you solve any equation for x? You try to get all of your x stuff with x's on one side. So I'm going to distribute, and then I can get all my x stuff on one side. Yes? I know this is going to be your favorite thing. Okay. All I'm doing is distributing this stuff. You see that? That's all I did. I just distributed ln 13 and I distributed ln 10. I don't know what this guy's doing there. Yeah. Oh wait, is it a 108? Well, that's why he's there. All right. Poor little 8 looked weird. That looks horrific. Dear God, do not put the decimals here. That makes it look even worse. Where are my x terms at? There's one. What's the other one? Yeah, there's, okay. So me, I'm gonna subtract this one over, because if I add that one over, that keeps most things positive. I like when things are positive. I'm not gonna make a negative mistake. So let me stop right now. Is everybody cool with what's happened so far? We took an ln, the power came down, and then I just distributed. That's all we've done so far. I know. Whatever ln 13 is, it's just a number. Oh, sure. You always got my handwriting to contend with. If you wanted somebody you could read their writing, you picked poorly. So I'm going to subtract this. I don't want to make it look like divisional. Sorry. And I'm going to add this. So we get all my x stuff together on one side, and I get all of my non-x stuff together. All I did was subtracted that over and added that over. That's all I did, right? Do I have all my x stuff together? Yes. Do I have all my non-x stuff on the other side? Yes. Can I combine these two things? Are these like terms?
They're both natural logs.
They're not like terms.
So you move the two on the, you move the two on the top. you
No,
move that.
let's not do that. You guys ready? Okay, so real quick. Side note. What's natural log of A plus natural log of A?
Natural log A squared.
Yeah. But can I say, isn't this just two natural log of A's? Isn't that right? What's X plus X? 2X. What's natural log of A plus natural log of A? Two of them, right?
Yeah.
Now, I like what Mike just said. I multiply the insides when I'm adding them, right? And also, do you see how the 2 would just go back up? So it also is natural log of A squared. Are you guys with me? So if I had, for example, 7 natural log of 11 minus 4 natural log of 11, what do I have?
3 natural.
3 natural log of 11, yes? So what is 7 natural log of 5 minus 4 natural log of 2?
Who knows?
Thank you. Who the hell knows? Are these like terms? I have 7 of these minus 4 of those. I can't put those together, right? I can't. I can't combine them using subtraction. Now I could move the 7 up, move the 4. I could do all that weird shit because it's logarithms. But fundamentally, those two are not like terms. Okay, so coming back to this. These are not like terms. But I see only one X. Yes?
What about the other example solution?
Say it again.
Like on the other page?
The other
You
page.
can combine those two,
Which one, sorry?
like 7 natural logs.
Yeah, sure. Yeah, so if this is the same as this, then I can combine the coefficients. If I have 7 tables minus 4 tables, that's 3 tables. If I have 7 tables minus 4 chairs, right? I can't combine those. They're not the same thing, right? Okay. We've done this kind of thing before. I know you already think I'm insane, but there's only one X on this side because I can pull it out. Don't they both have an X? So I can pull it. Now how do I solve for X? Why is it not by itself?
It's being multiplied.
It's being multiplied by this business, so I'm going to divide by this business, right? So that is the exact answer. Now we're going to try to put it in the calculator. Let me stop for a minute. And again, how many of these kind of problems have you seen so far? How many of these kind of problems have you seen? One. Right? So I try, students, you guys are so funny because I understand, you should want to understand things very quickly, but this is the first time we are seeing this shit. Some of the stuff in here you're not used to doing. Give yourself a break. I can see you're out there, and you should feel, you want to understand it. I get that. Realize we've only done one example. So you're not supposed to fully understand. But we've done this kind of thing before. We've done this kind of thing before where I factored an X out and then divided by what was there. We've done that before. Now, let's see if we can put this in the calculator. This is where you gotta be really careful with parentheses, because I got a top and a bottom. So anytime you're about to plug a big ass fraction in, I would write these parentheses for myself. We have eyeballs. We understand that the big ass division bar means there's a top, there's a bottom. Thank God the calculator does not have eyeballs. That would freak me the shit out, right? Are those donated from people? I don't know. Yes.
You could also use the alpha y one and get the 2 little boxes on the top and the bottom.
No idea. You have to show me. But let's try to do this. You ready? Oh, I see what you mean. Sure. So I'm going to put in there 3 ln. Now here's where it gets really trippy. I wish to God this calculator wouldn't do this. but it opens a parenthesis, I gotta close it, okay. So I'm still on the top, I haven't closed that parenthesis yet. Plus ln 108, close parenthesis, am I done with the top now?
Now you gotta
Close
close that
again.
one.
Yeah, I am done with the top, so I close it, yes, okay. Divided by, tell it this is all on the bottom. 2 ln 108, close that, minus ln of 13, close, close. Okay. So you get this funky ass thing. So what really sucks is the worse the equations get, the less we're able to tell if the answer makes sense. You guys understand? It's not, you can't just immediately know, well, that makes sense. Because the equation's much worse. So we got 1.82 roughly. So let me show you something kind of cool. Here's a way you can kind of check that. You ready? I think I've shown you this before, and if not, I apologize, but I have the answer right there, right? I'm going to store that. I've showed you the store button before, right? I'm going to store that in X. This is all extra, by the way. You don't have to do anything on that I'm doing right now. I'm just showing you how to kind of check this. 13 to the X plus 3 is supposed to be the same thing as 108 to the 2x minus 1. They do equal each other. So again, that is simply me plugging the stuff back in, but I'm letting the calculator do all of the work, which sounds good to me. Okay, I love you guys. This is the, just to let you know where we are in the book. Oh shoot, I think I got my spreadsheet open. Hold on. I'll show you all that. Just to show you where we are. Go away. Come here. Okay. So we just finished up 6 exponential logarithmic equations. And if I remember correctly, that's the last thing we do in chapter 6. So we just did 6. So just to kind of give you an idea of what's about to happen. This class, by the way, is everybody aware that this class is like 170 plus 175 together? I'm teaching a 170 right now, which is kind of funky because we're about to get into trig and 170 is trig. So we're about to get into the trig section that lives in the middle of our class, right? That's equivalent to the math 170. Is everybody with me so far? So there's going to be some algebra in these sections, but a lot less. Has anybody ever heard of trigonometry before? Yes, some of you guys. Okay. So if I say sine wave, you guys know sine waves. Very often, like a horror movie, there'll be an oscilloscope in the back, and it'll have something. Have you ever done any sound work in theater or just in band or whatever? Look at me trying to. And you might have some, and if you put the gain up too much, it makes the top kind of go. Alright, if you've never done that, you're fine. But these are various places you can actually see these sine waves and cosine waves. So chapter 7, 8, and I believe 9. Yeah, and 10. Yeah, 7, 8, 9, 10. They're all this trigonometry stuff, right? I'm not going to lay any of that on you right now. Right now we're going to end class. And then you can go and enjoy your break, right? I'm not doing that for any other reason than I didn't want to get into trig yet. We finished chapter 6. I'm not going to lay any trig on you yet. We'll do that next time. So I hope you guys have a good break. Do a little bit of pre-calc. Do a lot of relaxing and playing.
Are you gonna put this on the today?
Yeah.